Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I'm Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and on the television at Bell Express View Channel 972. You are always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday from 3 till 4 in the afternoon. And we are now in our 9th week of our 9-week course. This is our last week of our course. Our course ends. Our last day is Thursday of airing is Thursday, June 9th, and June 10th is the last day to submit your work. So a reminder that the key questions are listed at the end of each of your IL lessons, and you need to do all of them, submitting them all. This includes the check understanding questions, the activities, and the review questions. You need to give me full, complete answers that truly explain what it is that you're thinking and that you're actually answering the question. But you can do it either by hand or electronically. Either way, I'm fine with. If you would like to write in your workbook, feel free. The spaces are small. It's your workbook. You can decide if you want to type it up in Word or Google Docs are the best files for me to open. But if they don't work for you and you need to do something else, that's fine too. Again, a reminder that June 10th is the last day to submit your work. That is this Friday. You need to submit all of your work as well as your culminating assignment if you're hoping to complete the course this term. There are 3 different methods for submitting your work. The first is to scan your work and send it electronically. So if you've written it out by hand, you can scan it in through a smartphone. So the iPhone Notes app has a scan function and the Android Google Drive app has a scan function. Then you can send it through email to studentwork@nnec.on.ca and CC it to bronwynslade@nnec.on.ca. Or you can also send it to me through Facebook Messenger at bslatewahsa. The second method is to drop your work off in Sioux Lookout. We have a mailbox, an outdoor mailbox at our location, 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance, so you can just put it there at any time. The third method is to hand your work into your DEC. Your DEC can then either send it through the Express or can fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bslatewahsa. All of our radio Zoom classes are recorded and uploaded shortly after airing on to YouTube. They're all under a playlist called SVN3E, and I share them on Facebook. I do upload them all to YouTube, though sometimes I forget to share them to Facebook. So YouTube is the best place to go and find them, though you can find the whole channel through my Facebook as well. Also, there is a list of supplementary videos, which has all of the videos that we have watched through our class so that you can see it there. Science is a really visual subject. I integrate as many visuals as possible, including videos and diagrams. So connecting with the video is really going to set you up for the most success. If you can't join me live through the Zoom class or access them through YouTube, please let me know, and I'm happy to send you a copy of the videos on a USB key or something so that you can still access them. If you have any questions or concerns, please reach out and contact me. I am here to support you and would really love to get you through the course so that you get your credit. My email is bronwyn.slate@nnec.on.ca. My Facebook is bslatewahsa. You can call me at the office at 807-737-1488, and my extension is 2209. You can also call us toll free at 1-800-667-3703. Again, our last day to submit work is this Friday, June 10th. After that, we will not accept any more work. And if you don't get it done in time, then you don't get your credit. All right, I think it's really important to position myself as an educator within positions of power that I have. I have white settler ancestry, I have white privilege, and that gives me power within our society as well as within education. I work to disrupt this cycle and to address the power that I do have and how I may have learned things differently than many other folks, and I may have not have learned a complete and true story of all of our history and our way of understanding science and such. So I recognize that and work to disrupt that cycle. I live in Northwestern Ontario on the traditional territories of the Anishinaabe people and work to incorporate some of their teachings that into our science understanding. It is a work of progress. It isn't something that I am not proclaiming that I'm an expert or have done very well this year. It is something that I will continue to work on as I develop this course. As it is my first year teaching this course, I have learned lots and I have lots to continue to learn about and to things I'm sure I need to unlearn in order to authentically share wisdom and knowledge from Anishinaabe and other Indigenous Inuit and Métis communities in an appropriate way as a white person. But I also have noticed that our textbook is really Eurocentric. It may use some problematic language. There wasn't anything too blatantly obvious that I found, though I may not recognize it because of who I am and how I walk in the world. But I did notice that it did ignore Indigenous, Inuit, and Métis knowledges as well as experiences. Many of the scientists, all of the scientists and many of the communities that it talked about were white communities and were not, just didn't represent a whole story. So I did try to incorporate some other perspectives as I could. It is something that I continue to work on. If you have any feedback for me, please feel comfortable sharing it if you would like. All right, so we are in our last week. This is our review week. Every day this week, we will review 1 or 2 units. There are 7 chapters in your workbook that we covered. So we have 4 days. So most days we'll be reviewing 2 units. So our final assessment is not an exam, but a culminating assignment. So it is a final project that you need to do. It covers all 23 of the lessons. So you can integrate knowledge that you learned from all 23 lessons. It's not like it says, this is from lesson 17. This is from lesson 5. You integrate your understanding from all of them as all of those lessons are very interconnected. Science is very interconnected. And this really shows how we have things that may have felt very disconnected as we went through them, but you can see how they are connected. It is an open book assignment. So you have access to your assignments. If you have handed them in and I've returned them, then you have marked assignments. Otherwise, you don't. At this point, you are not going to get anything that you handed at this point will not get back to you before your culminating assignment is completed or needs to be completed. So maybe you want to keep a copy of your assignment so that you have your own answers. But you can have access to all of the YouTube videos, all of the supplementary videos, everything that we talked about through our lessons. And you have access to your IL booklet in case there's any information in there that you find to be useful. It is not timed. It's not like an exam where you only have 2 hours, but you do have a deadline. So that deadline at this point is June 10th. It is the end of this week. So if I get it to you, if you hand in your work and I give you your assignment, then you have until the end of this week to complete it. And the structure might be is a bit unfamiliar. It's not exactly like your work course has been very direct answering questions, individual textbook questions. And this assignment is not like that at all. All right, so let's look at the lessons in the first 2 units. So lesson 1 was components of soil, water, and air. So just to go over our highlights, and then we're going to answer some of the review questions. So soil is made up of air, water, minerals, and organic materials. The mineral composition of soil affects the porosity. So how the sand, if it's made up of how much sand in comparison to silt and clay, and how all those three ratios work up, affects how easily the water runs through the soil. Water, we talked about how it's a universal solvent because it has polarity. So all of the molecules are polar, and that means that any polar substance that it comes in contact, the positive ions are able to attract the negative ions of the other solvent and the other solution, and the negative ions attract the positive ions in the solution, and so then that we're able to dissolve and break up those other solutions or materials. We talked about the water cycle, which hopefully is fairly familiar to you in terms of how our water cycles through our systems. And then we talk about how acids and bases work and the pH scale to get a bit of understanding that so that we can move on to acidic precipitation. Then we talk about air and how it's made up of various gases. It's not just oxygen, particularly, I believe 79% is made up of our air is made up of nitrogen, and then carbon and oxygen are also a very strong presence. Okay, so what I decided to do for part of review is to answer a few of the review questions from each lesson, just so that to engage in these topics a bit. Don't copy my answers down exactly and give them back to me as your answers. That is not going to set you up for success. So number 3 on page 9, do you think one environmental sphere is more important than the other two spheres? Support your opinion with 2 or more supporting statements. So the spheres that are talking about are the air, water, and earth spheres. This is an opinion question, so it's not finding the right answer. It is sharing your thoughts and supporting it. So I don't believe any sphere, any environmental sphere is more important than the others. So that is our first part, is making sure that we have a clear statement that I know. What do you believe? Do you believe that there's one more important than others or not? And it's an opinion. I'm not asking you to replicate the same thing. I'm asking you to have an opinion and back it up. So support your statement with at least 2 or more supporting statements. So this is my opinion. I gave it to you. And now I need to give 2 supporting statements about why. 3 spheres are interconnected share nutrients and minerals between them. Animals, we get nutrients and minerals and the different spheres make them accessible to us. We need we need nitrogen in our systems, but we can't get it from the air. So the fact that the nitrogen cycles through the 3 spheres means that it gets into a way that we are able to get it. Sorry, that was bad writing. It's hard to write on this little screen and talk at the same time. Question number 7. Could you have good soil at a sandy beach near a lake? Explain your answer. I would say it is unlikely. Good soil. This, I mean, for growing things. As it depends on how you're putting your value on. So good soil for letting high porous soil so that lots of water runs through it. Yes, that's going to be good. But for growing things, no. At a sandy beach, because sand has a high porosity, which means water runs through, takes nutrients away. I apologize for my messy writing. I'm trying to do it relatively quickly in order to cover lots. That might not be the most helpful. Okay, so this one I won't write out. I'll just answer quickly. Number 10, if you spill the liquid with a pH 7 on your hands, should you be worried? Why or why not? You don't need to be worried because pH of 7 is perfectly balanced between acidity and alkalineness or basic. It's halfway between being an acid and a base. So that means that we know that both acids and bases, the stronger they are, the farther they are from neutral, they are more likely to burn your skin and harm your hands. But with an acidity of 7, pH of 7, means that it's not acid or basic, and therefore it will not burn you. Okay, then let's look at lesson number 2, the effects of human activity on soil, water, and air. So soil, we talked about the effects in terms of deforestation, urbanization, erosion, chemical fertilizers and pesticides, industrial chemicals, and how they all destroy the soil. Then we talked about how recreational, industrial, and everyday human activities pollute our water. And then in terms of burning of fossil fuels that leads to air pollution and greenhouse gas effect, and how the climate crisis is having detrimental effects on both humans and the natural world due to our actions and air pollution. And so the review questions for this one, number 2, many corn farmers leave the stalks of the corn in the ground after the corn has been harvested. Give one reason why this is a good method of helping to conserve soil. So as the corn stalks biodegrade, they return nutrients back into the soil. Another suggestion, another way you could look at it is that they help keep erosion as they hold down the soil and keep it connected so that they don't, wet rain doesn't just wash away the nutrients. Number 6, storm drains capture extra water on streets and typically drain straight into a river or nearby lake. Why can this be a problem for living things in the river or lake, especially after rain showers? So if we think about it, I'm going to draw a diagram. You can draw a diagram sometimes. If we have rain, that's all over the place, really. If you don't mind. We know that our precipitation is acidic. And then if we funnel all of this rain, various places, into a sewer system, we've taken all of that acidness and put it together, and then we are dumping it into a natural body of water. You love my pictures, I know you do. I'm the best artist ever. I'm not at all. So what's going on is this can be a problem for the living things in the water, is because yes, rain was going to happen here, right? And a certain amount of rain, acidic rain, would fall into the lake. But if all of the other rain, if it, instead of seeping into the ground, if it gets shuttled into a sewer system, and then it all together goes into the lake, that means that all of this other acidic rain is being pumped into this lake, and therefore the acid level of this lake is going to increase, which means that many of the plants and animals will not be able to survive because they can't survive in more acidic areas. Right, number 11, describe the two changes in Earth's normal average weather conditions that are due to climate change. So one change is extreme precipitation. So by that, I mean like significantly more snow. So this year in Sioux Lookout, and I think in probably most of Northwestern Ontario, we got a lot of snow. We had 6 months of heavy snow, basically the entire time, from November until the end of April, middle of May even, was it? I don't even know when it went away. Basically, we had 3, 4, 5 foot tall snowbanks of snow. And then now we are getting consistent rain, a fair amount of rain. So that is affecting, our snow melted really, really fast and has now all gone into our lakes and rivers. And we are experiencing a lot of flooding because of the amount of snow that we had that melted really quickly and the ground was saturated, it didn't have anywhere to go, so it just is holding in the lakes and rivers, which means that it's flooding, and we're continuing to get rain. In other years, we have had really, really dry years. We have not had very much snow, and we have not had very much rain, and so then we've been really susceptible to forest fires because everything's been really, really dry. So that extreme precipitation, where some years we have a lot of precipitation and other years we do not have a lot of precipitation, is a result of climate change and the weather patterns shifting and changing as the temperature of the earth is increasing. So along with that, so we have extreme precipitation, but we also have extreme storms. So we're having more hurricanes, more and stronger. And tornadoes in areas that didn't have them before. And these storms, these patterns have shifted due to the change in the temperature of the earth. Okay, lesson number 3. We are looking at common methods of sampling and monitoring soil, water, and air. So our highlights for this lesson, we talked about soil because we're monitoring sampling. So we talked about core soil testing and how we looked at soil profiles and how we get different information at different levels of our soil. So topsoil is at the top, and then there were various horizons all the way down to bedrock. And each of these different layers have different nutrient compositions and different porosities different things going on, and they add to the health of the soil in different ways. Then we talked about water, and we talked about how water is sampled and tested. And we spent a bit of time looking at boil water advisories and how there are many places in Canada, particularly First Nation communities, that have boil water advisories and do not have access to clean, healthy water that is safe both for drinking, consuming, and also for washing. Many Indigenous communities have their water gives them rashes or boils on their hands, on their skin, and they can make them ill as well if they don't boil the water. So either people are boiling water in order to consume it or use it, or they are buying bottled water in order to have safe water. And this is really, really quite concerning. There has been some progress made in the last decade or so in terms of that shifting so that there's not as many boil water advisories, but still it is a concern. It is still an issue. And the fact that it is particularly an issue for First Nations communities and not white communities or more urbanized communities is really, really problematic. This is not just an issue of being in a remote area. In Southern Ontario, this is still an issue. And even in even though it's close to large urban populations, some First Nations do not have access to clean water. And then we talked about air quality. We talked about how, because many toxins are put into the air, are colorless or scentless, and so there's no way to know just by sensing using our human senses. So using a probe stacks, which is where much pollution is, many chemicals are entered into our air. So probes are put into stacks, and then air is shuttled sort of out of those stacks to be tested and to make sure that there's not more of certain chemicals or vapors in the air that sorry, lost my train of thought. Then there's certain laws about how much can actually be in there, and then companies will have to change if they are not following the environmental rules. I would talk about the air quality index in terms of measuring the outdoor air quality, and is it safe for all of us to be out there, or if breathing in that toxic air, how much of an effect it will have. In Canada, we are fairly lucky, and we don't experience too much air pollution or smog compared to other places in the world. Yes, some places it definitely is higher than other places. And yes, we still are all impacted by air pollution, but in some places in the world, it is really quite substantial. Okay, so how do cover crops help improve soil quality? So cover crops, think back to this unit and think about how cover crops help to make it so that there are not they protect the soil from erosion. So they shade cover crop shade other crops. And help them grow. This helps the soil health as various nutrients are cycling through. And it protects the soil from erosion. Similar to that corn question, really. Number 5, when a water sample is collected using the depth integrated sampling process, why is the sample called integrated? So remember we watched a video about, I'm gonna draw another picture, where we had a boat and we had a person sampled in the water. They had this really, really long tube and they put the long tube in and then they capped it. They pulled the long tube out and then they capped the bottom. And now there's water trapped inside the tube. But once they had that tube full of water, then they shook it. So the water sample is integrated because all of that water, it's not about layers. Think back to the soil where we had the soil profile showed us very distinct layers. In the water, we don't have distinct layers. Though there are things that are more common at the top and more common at the bottom, but so shaking that tube of water means that all of that water is integrated, it's shared about. So we don't know if this is something that's happening more at the top or the bottom, but really because water is fluid and we don't know anyway. It's getting the general health opposed to thinking that we can find specific information about the top or the bottom. That's just not realistic. Number 9, why would people with asthma and other respiratory problems have to wear a breathing mask or stay inside if there was an increase in fine particulate matter in the atmosphere? So fine particulate matter are small particles like dust. That when inhaled, irritate the lungs. So if you already struggle with breathing, this can make it much more difficult. Okay, and that is lesson 3. Now that was unit 1. So now we're moving on. So we're talked about those 3 spheres that are pretty essential to all life. And now we're moving on to lesson 4, which is the beginning of chapter 2. And we're now going to be talking about ecosystems. So lesson 4 was cycling of substances in ecosystems. So we talked about how there are living and non-living elements in an ecosystem. So the rocks, the soil, the sunlight, the air, all of those things are part of an ecosystem. They have an impact, the temperature, the moisture content, and the humidity and water content. All of that impacts the ecosystem, right? So a dry desert, the lack of moisture means something different opposed to being in the rainforest where there's a significant amount of moisture. Or a cold desert versus a hot desert, right? The temperature affects the climate or affects the weather and the climate of the ecosystem opposed to is the overarching climate. And then there's living elements. So there are producers, consumers, and decomposers. So producers are plants that can take their nutrients and the things that they need from sunlight and from the soil, and create their own, putting those things together can create what they need to survive and to grow. Consumers eat producers or eat other consumers that eat producers. So generally animals, though there are some plants as well, insects, things like that. And then decomposers are the plants and animals that deal with the waste products from the producers and consumers, and their how to break down all of that matter. So this are like fungi and bacteria, worms. There's a variety of different decomposers. So then we talked about the interconnected cycles of these substances. So what are the producers, consumers, and decomposers cycling through and reusing in order to sustain life? So particularly we looked at oxygen, carbon, nitrogen, phosphorus, and sulfur, and each of them have their different cycles that where these nutrients move throughout in different ways with help of the producers, consumers, and decomposers, that they transfer from one state to another state. And then we talk about biosolids and how this is a method of dealing with human waste in terms of figuring out what to do with it and how it isn't just become waste or isn't just a pollutant, but how it can be helpful, though there are some concerns as well in terms of those biosolids, using it as fertilizer or to help grow things. Okay, review questions. Number 1, this is on page 35. Describe the difference in roles between a producer and a consumer. So a producer gets its energy from the sun, water, and soil, so the non-linking elements. Whereas consumers get their energy from living elements. I'm just going to say, so that's producers, consumers, and decomposers too, I'm sure. Identify and describe one key difference between natural ecosystems and human activity systems. So natural ecosystems have those producers, consumers, and decomposers. Human activity systems try to replicate, but human activity systems do not have very good decomposers. In a healthy, thriving ecosystem, natural ecosystem, then everything that they need to thrive and survive, they were able to get through that interconnectedness of the producers, consumers, and decomposers. There isn't extra waste. That is all used by those 3 groups and cycled through. So everybody gets what they need, and there isn't something that's polluting those ecosystems. With humans, we end up polluting the ecosystems because we don't have a good system of decomposing. We don't have a good system of getting rid of our waste, whether it's biosolids or like human waste or chemical waste from the manufacturing plants that we have, from the household garbage. Think how much garbage is at the dump. Just all of those things we are consumed. Capitalism makes us really, really tempted, really prone, really encouraged to consume, and then we are left with a bunch of waste, and we don't have a good way of getting rid of it. We just dump it in the ocean, on land, shooting it into space, putting it in someone else's environment, and this is quite harmful. Then we're concerned with the use of biosolids. So introducing heavy metals and pharmaceuticals. don't know how to spell that word. That's not right, but pharmaceuticals into our food, into our growing, into the environment that grows our food. What are the long-term impacts of that? We don't know. All right, then lesson 5, how carbon footprints measure the impact of human activities. So carbon footprints we talked about in terms of it's a measure of the amount of greenhouse gas emissions that are produced. We talked about this in terms of countries or larger cities or things, but also about the personal reflection of how we each have a carbon footprint. So there are inequities within this. The reality is that the white minority create the most emissions. So those with white privilege and the power that becomes associated with that, and disproportionate wealth in white communities based on colonization and oppression, really, is where that all comes from. Those folks are the ones who are creating the most emissions. They're having the greatest impact on our climate. And yet the global majority, the majority of the people in the world are not white. So these people are the ones who are most impacted, are going to be the people who are the first climate refugees. There already are some. These are the people who are having a harder time having access to clean water and healthy food. These are the people who are losing their homes. I guess that would be climate refugee in terms of the, like you think about Hurricane Katrina in New Orleans and how the poor population, which are the Black populations, had a higher hit rate. Not because the weather cares, but because of who was warned and who was able to get out first. And those were the wealthy and the white were the people who were protected, and the poor and the Black communities were not. So these cycles of oppression continue and are going to have a greater and greater impact as the climate crisis continues. So we talked about reducing our carbon footprints, and we talked about what are some individual actions that we can each take, and then also what is the structural change that needs to happen, and talking about how it isn't just an individual actions that are going to make the difference in the long run, but really how it's about we need to change our way our society works in order to actually make long-lasting, meaningful change. So number 4 on page 43, if you purchase a bottle of water from France at your local store, what are some of the cradle to grave costs that are not included in the cost of the water? So cradle, that just means the life of the cost of the bottle of water. So the extraction of oil to make the bottle, plastic bottle, factory, costs, and to make the bottle. Costs of shipping the bottle. This is going to use some sort of fossil fuel. Right? Because either by plane or boat, it's still going to take the shipment to come from France. And then also probably a truck to get from wherever it's shipped from. Like it's not going to fly directly to your local store, so it's still going to have to get trucked in. And then the cost of disposal too. So is this recyclable? get recycled, or dump. Then identify 3 activities you could personally do to reduce your carbon footprint. So I could walk to work more often and not drive. I could be conscious of my e-waste. Not upgrade my devices. And I could have 1 less child. We know that it makes sense. The more people populate, the bigger the global impact. It's like a ripple effect. Okay, lesson 6, how human activity affects ecosystems. So oil spills we talked about. And so we talked about how kelp and seagrasses die, but also how other algae thrive and then become excessive. So then they steal oxygen and space from other plants and animals that need it. And many animals die in oil spills in the water. Similarly, on land, forest and land animals also die due to pipeline leaks. So leaching of oil into the ground affects both the plants, kills the plants, and has a ripple effect on the animals as well. Oil spills have a greater impact generally on water because it is able to spread faster. Then we talk about acid precipitation. And so the increase of some nutrients and the decrease of other nutrients means that trees and other plants do not have what they need to grow strong. So acid precipitation cancel out some things, which means that plants don't have that they need, and then adds things to the soil that they might use, but it means that they are not necessarily as healthy. Lower pH levels in water are toxic to some animals and dramatically change food chains. So this has a cycle of that negatively impacts ecosystems, and that it can take years, decades to recover from both oil spills and acid precipitation. There are development of laws, but really it's a really big issue, and we're not quite there yet. Our laws are not developing as fast as we're having impact on the environment. So one way oil enters the ecosystem accidentally. So oil drilling like accidents. Can't think of another word for accidents, so I'm not using the same word, but explosions. I wonder though if those can be really counted as accidental, because it's not like they're if we weren't there drilling, they wouldn't happen. And then intentional, we talked about how in World War II, I believe it was, that releasing oil into the ocean was an active war strategy. And it had a huge impact on the natural environment. And number 8, using figure 2.16, describe how acid precipitation impacts on the release of key nutrients and heavy metals. So here, looking at this diagram, you can see how with the water without acid precipitation, how there's aluminum, calcium, hydrogen ions, magnesium. The soil has a pH of 6.0, and there is more of some things than other things. Whereas, and how deep it goes. When we have acid precipitation, then we've increased aluminum, calcium, hydrogen ions, and magnesium. We've increased all the amount of all of them and how deep they penetrate, which means that they get into the lakes and streams or the underground water, which makes everything really much more acidic. And number 10, why is Ontario one of the provinces hardest hit by acid precipitation? Because we have a lot of manufacturing plants. So and then also car transportation, like personal transportation. The fact that we have the highest population in Ontario, a lot of our people live in Ontario, and therefore we have a lot of vehicles on the road. And then quick, before we run out of time, lesson 7, invasive species effects, monitoring control of them. So native species are species that originally thrive in an area, whereas non-native species come from somewhere else and might do all right in the area, but they don't take over, whereas invasive species come from somewhere else and they take over and make it hard or impossible for the native species to thrive and survive. So there are monitoring systems in terms of checking and testing to make sure that ecosystems are not being impacted by non-native and invasive species. And there are databases developed for prediction for future change of these areas. And then there's a control, there's prevention, early detection and elimination, and containment and management, and then ecosystem restoration are how we control if invasive species are something a concern. So question number 1, figure 2.21 illustrates the increase in the number of non-native or alien species over the past 200 years. Why have the numbers continued to increase? So looking at this diagram, you can see that really there was not a lot of invasive species in Canada, and then it dramatically changed in the 1900s. So we can think about this is when travel has increased. So many more people have come from other places in the world, and along with people have come invasive species, as well as shipping things all over the world. Now we have just so much interconnectedness of people and stuff all over the world that species are very easily bugs and animals. People import animals and plants come really, really easily from all over the place in the world and then invade our ecosystems. Number 5, explain how predators can help to control the population of invasive species. So I was thinking about the example of beetle that I never remember, and the purple loose leaf, and how the purple loose leaf is or loosestrife, which is the plant that was taking over our marshes and then importing the non-native species of the beetle, but they only eat the purple loose leaf, and so they are able to control that, whereas nothing else could, and that beetle doesn't eat anything else, so it doesn't harm anything else. And then last, what do you think would happen if the control process failed after all methods of control were used? So then I just feel like the invasive species would take over until we came up with another solution. I think that scientists would continue to test and continue to try things out and to problem solve, but it would be in a bit of a holding pattern of invasive species taking over until we could figure out something new that might control them. And that is our review of lessons or units 1 and 2. Again, it was a super rush. It only can be a super rush. We have lots to cover. This is just a reminder of what we talked about, what we learned about over the course of this course. And it's not meant to be a full deep understanding. So go back to the original lessons if you need to review anything. Thank you so much for joining me today. I hope you have a lovely day and look forward to reviewing with you for the rest of the week. Which